Hi girls, how are you? Welcome back to a little bit of organic chemistry, which we're going to look at today. This is very short because what we're looking at today is we're just looking at the physical properties of some of the alkanes that we looked at the last day. Okay, so physical properties are properties that relate to how something appears. Okay, your physical properties are your hair color, your height, things like that, right? The physical properties of chemicals are their boiling point, melting point, color, solubility, things like that. So we're not looking at their reactions yet. We're only looking at how they appear to us, basically. All right. Now, what I've got in front of me here is a list. Now, you'll have seen this. This is a list of the noble gases. Can you see that? So you'll find these in your periodic table. This is group 8, the noble gases, or inert gases, they're sometimes called. Helium, neon, argon, krypton, xenon, and radon. Okay, so that's how they go down the periodic table. And this is the number of electrons, excuse me, in each of these atoms. Okay, so you've got 2 in helium, 10 in neon, 18 in argon, 36 in krypton. You get it, right? And alongside that, I've made a list of the boiling point of each of these noble gases. Okay, so this is the temperature at which they turn into gas, right? So what happens is, as we go down the periodic table like this boiling point, as you can see, increases. Remember, these are negative numbers. So this is increased. This is the lowest one. And these are increasing. And you might remember we looked at this. This is old stuff, okay? We did this before Christmas. The point of all this, you might remember, is what it's demonstrating here is why is the boiling point increasing? Well, the boiling point is increasing because there are greater intermolecular forces between these atoms holding them together. And the greater intermolecular forces are due to the fact that there are van der Waals forces between the atoms. So you might remember we talked about that. What are van der Waals forces? They're induced dipoles brought about by electrons in a molecule moving. Okay, we talked about that. And the moral of this story, if you like, is that the more electrons there are, the more movement of electrons there must be, the more dipole is induced, the greater the intermolecular force, and the higher the boiling point. That was kind of the moral of that story. You all did a graph. You should be able to dig it out in your books with the number of electrons on the x-axis and the boiling point on the y-axis. And that was the point of that whole story, was to show you that the more electrons we have, the more induced dipole there is, the greater the van der Waals force, the higher the boiling point, right? Now, why am I showing you that when we're doing organic chemistry? Because if you look here, and we look at these guys this time. So this is the alkanes now. Okay, can you see that? So I'll get rid of that. Sorry. Yeah, there we go. So you've got methane, ethane, propane, butane, and pentane. Okay, and I've drawn each of the structures there. You can see that, right? I've drawn them all out. And I've done a similar thing. I've listed the boiling points. And what do you notice? It goes from minus 162, minus 129, minus 42, 0 to 36. In other words, it's a gas at room temperature, but then it's a liquid at room temperature. So what's happening here? What's happening here is that the more electrons there are in the molecule, the more induced dipole there is, the greater the intermolecular force, and therefore the higher the boiling point. So we're seeing the exact same pattern as we see with the noble gases, right? Have a look at methane. There's 1, 2, 3, 4 pairs of bonding electrons here, whereas in ethane there's 1, 2, 3, 4, 5, 6, 7 pairs of bonding electrons. Propane, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. You get it, right? There's more electrons here than there is here. There's more electrons down here than there is here. The more electrons there are, the more they move around. The more they move around, the greater the induced dipole, the greater the induced dipole, the greater the intermolecular force, which means the higher the boiling point. Remember at the time we compared it to going to a gig in a small little pub compared to a gig in the O2 or something, and the effect of somebody pushing in behind you. When you're in a big stadium or in a big crowded area, the effect of being pushed around is much greater, isn't it? Than when you're in a little pub or in a little room. So a crush can get very serious in a big place. And it's kind of the same thing here. The more electrons there are, the greater that force is. All right. So that's kind of the moral of the story today. It's just that when we're looking at the physical properties of alkanes, the longer the chain, the higher the boiling point, due to the fact that there's more electrons, a greater induced dipole, and greater van der Waals forces. That's a really important point and something that we're going to come back to again. Right. That's all there is for today. Hope all's going well. Bye-bye.